everyone. Today we will listen about digital anti-forensics from presenter of Stefan Gostojic from the Faculty of Technical Sciences.
Okay, hi there. I'm glad to be here, as you had an opportunity to hear. My name is Stefan Gostojic, and I'm going to talk about digital forensics and digital anti-forensics. Before coming to the point, I will briefly introduce myself. I work as an associate professor at Faculty of Technical Sciences in Novi Sad, where I head newly founded digital forensics lab. I'm also participating in a research project that explores how artificial intelligence can be applied to digital forensics, and I'm preparing a course on digital forensics that is supposed to start in the next academic year. I'm also working as a court-appointed IT expert witness in my own capacity, and roughly the half of the cases I took were digital forensic cases. This talk is going to cover several topics. I'm, in the beginning, going to tell you that this is going to be an introductory talk. And since I see a lot of young people here, I think that I haven't made a mistake when I prepared the lecture. After general introduction in forensics in general and digital forensics, I'm going to cover some of the methods and tools used in computer forensics, network forensics, and mobile forensics as the main areas of digital forensics. I'm going to talk about some anti-forensic methods, and after giving some examples, I'm going to conclude the talk with some references that you can follow later on. So, to begin, one simple definition of forensics is that is a scientific analysis of physical evidence. For example, evidence that can be found at the crime scene. So, I have a question for anyone in the audience. What does scientific analysis mean? Can you try to answer that question? So that basically means that we have to follow the scientific method. We have to put some hypothesis and then test that hypothesis using accepted scientific methods. A little bit more detailed definition would say that digital forensics in general is a process of identifying, acquiring, preserving, analyzing, and presenting evidence using scientifically and legally sound methods. So we can see that forensic process has several phases or steps, and that each activity has to be scientifically sound, and what is even more important, it has to be legally sound. If we do not follow the book, then those evidence won't be accepted by the court. So I mentioned another commonly used term, evidence. In general, it is something that supports an assertion. But legally speaking, it is something legally submitted to a court to ascertain the truth of a matter. So can you give me some examples of evidence in general? Okay, and that is the first example I'm going to give you later on. But before that, I just want to mention that we usually want to answer so-called the 6 V's of investigation during forensic investigation. And as you'll be able to see very soon, not all those questions start with W. So we want to answer the what question. What happened? Who did it? Why did it happen? Where did it happen? When did it happen? and how did it happen. And we have to take that in mind later on. So just a brief history of forensics. Many people think that it is a relatively new professional discipline, but as early as in the 20th century, ancient Chinese were the first to distinguish between natural death and criminal intent in suffocating victims. What is more familiar to most of the people is some other branches of forensics. For example, in 1835, Henry Goddard, I'm not sure that I pronounced the English surname correctly, became the first person to use physical analysis to compare a bullet with a murder weapon. And also in the 19th century, Sir Edward Henry developed a system for classifying fingerprints that was used in criminal investigations. He was not the first who, let's say, invented fingerprints, but his method was most widely used. I'm aware this is okay, and now we are, let's say, skipping 1 century. In 1987, the first case went to a trial using DNA evidence, and one man was acquitted from rape and murder using that evidence. I'm aware this is an international conference, but I want to say something about history of forensics in Serbia. Most of the people from Serbia heard of Archibald Rice. He was the first forensic practitioner in Serbia, and he was also the first principal of the first police academy in the country some 1 century ago. So, this is also my first example. We all know that each person has individual fingerprints. And when we touch some object, for example, a murder weapon, we leave those fingerprints on the object. During the forensic investigation, that investigation passes through several phases. For example, if we are examining the fingerprints, first we have to identify the evidence. And that is not something that is as easily done because we usually cannot see fingerprints with our bare eyes. So we have to apply a powder or a spray to see the fingerprints. Then we have to acquire the evidence. For example, using the oldest technique, we can use a transparent tape to leave the fingerprints of the murder weapon. And then we have to preserve the evidence, for example, by scanning that tape. Later on, the evidence is analyzed. In the past, people had to manually compare fingerprints with police records, but now that can be done automatically in few seconds using software methods. And finally, the evidence has to be presented to the court. That means that the examiner has to give a written and an oral report to the court. So the second example could be DNA evidence. Let's suppose that in the same case, a murderer left a cigarette butt at the crime scene. So we have to pass through the same phases. First, we have to identify the evidence. Compared to the first case, it is much simpler because we can see the cigarette butt with our eyes. We have to acquire the biological material from the cigarette butt. We have to preserve the biological material. That is not as easy as preserving the fingerprint. Then we analyze the biological material by extracting DNA and finding a match in the database. And similarly to the previous case, we have to present the evidence to the court. So now I'm coming to anti-forensics. We could say that anti-forensics is a process of compromising digital forensic methods and tools. For example, what would be some anti-forensic method in our first example? I haven't heard it. Can you just be a little bit more louder? Well, that could be a method, but we could also use, for example, latex gloves. And we won't leave fingerprints in the first case. And for the next example, the DNA evidence, what could be? Well, that is an option. We can stop smoking, but it turns out that it is not as easy not to leave biological traces as fingerprints. So this is much more complex thing to do. So now we are coming to digital forensics, and digital forensics is a special case of forensics in general. So we could say that it is a process of identifying, collecting, preserving, analyzing, and presenting digital evidence using scientifically and legally sound methods and tools. So the focus is on digital evidence. What is digital evidence? Okay. Different kind of artifacts, files, logs, laptops, or to be more specific, solid-state drives in laptops, etc. But in general, it is information of probative value, information which can be used in court that is stored or transmitted in digital form. There are several digital forensic principles, and most of those principles can also apply to any kind of forensic investigation. The first principle was already mentioned, and it says that we have to use scientifically accepted method and tools. The second principle says that we have strictly to follow rules of procedure. That means that if you are a forensic investigator, you also have to know the law. If you made a simple mistake, for example, you forgot to invite someone to be present at the investigation, that evidence won't be valid at court. We have to maintain chain of custody. That basically means that there has to be a record where evidence was at each particular moment in time, so no one unauthorized could interfere with evidence. And the investigation process has to be documented. I mentioned scientific method a few slides before. The idea is that another party, for example, another forensic examiner, can repeat the same process and get exactly the same results. And the last principle says that we should not alter data on any medium. However, there might be some exceptions, and I'll come to those exceptions later on. So we already mentioned 5 phases of forensic investigation, and I'm going to give some example of those phases in digital forensic settings. First, we have to identify digital evidence. That is not as easy as identifying cigarette butts. Can any one of you give some examples? What can be digital evidence? We already heard something. Someone mentioned log files, but usually when we come to the crime scene, we are going to notice something else. You said memory dump. Okay, but first we have to get the memory dump. So usually we're going to notice some devices, laptops, smartphones, or some media, thumb drives, SIM cards, whatever. And for example, that could be a hard disk drive in some desktop computer at the crime scene. Then we have to acquire the evidence, and Do you have any idea how can we acquire evidence from those devices? For example, if we found a thumb drive or hard disk drive at the crime scene, what can we do?
First need to know what you're looking for. Some drive can contain millions of files.
Well, that is true. We usually know what are we looking for, but sometimes we don't. So if I heard correctly, someone said that we can boot up device and look at the files. Am I correct? Okay, we can do that, and people sometimes do that, but as it turns out, that can invalidate the legal validity of evidence in court. Do you know why? Exactly. So we can use special software or hardware tools to be sure that we are not going to alter the data. We'll come back to those tools later on. We have to preserve the evidence compared to some other evidence type that is not as hard, but we have to take care of protecting that evidence using physical, technical, and organizational controls. Evidence, digital evidence, is just a piece of information. As any other information resource, it has to be protected. We have to keep chain of custody, and what can also be interesting is that some physical media degenerate over time. So if we have some court case that lasts for many years, compact disks or hard disk drives maybe won't be readable anymore. Maybe you can try to, I don't know, there's a lot of young people, but if you used burned CDs 10 or 15 years ago, it's a very high probability that those CDs won't be readable now. So now we acquired and preserved evidence. We have to analyze the evidence. Well, this phase can really vary because it depends what are we looking for, and it depends on the task. There are many special tools which can be used to analyze digital evidence. Those tools can be either commercial, open source, or you can even write your own tools. I'm a supporter of open source software. However, in digital forensics, commercial tools are much more powerful than open source ones. And at the end, we have to present that evidence. As previously said, basically, you have to give a written and oral report and maybe answer some questions at court. So what is the main function of digital forensic investigations? In all the examples I used previously, I was talking about some criminal proceedings. Someone committed a crime and we are investigating what happened. But that might not be the only reason why we are using digital forensic methods. It can be also used in civil proceedings. There is a related discipline called e-discovery, or electronic discovery, which is concerned with collecting evidence that can be used in court. And we have some other suggestions of why would we use digital forensic methods. We had, for example, opportunity to hear this today in one of the previous lectures. We don't need to collect evidence that is going to be presented at court. For example, we can also practice digital forensics in some commercial settings. For example, during incident response. When something happens, we usually want to know what happened. We want to answer to those 6 V's of investigation in order to stop the intrusion and to make sure that similar attacks don't happen anymore. And it can also happen in some military and national security settings. Those investigations are rather similar with criminal investigations, except you don't have to take care of legal restrictions as much as previously. So, digital forensics can be divided in several areas. The traditional digital forensics is called computer forensics. And it can be divided into disk forensics. You can guess what are artifacts that we are investigating. Disks, file systems, files. Memory forensics, we are investigating artifacts found in volatile memory. Operation system forensics, we are investigating log files, registry in case of Windows, cache files. Document forensics, or database forensics. In the last decade or two, internet forensics also became popular because most of the people are using PCs to communicate. And another traditional branch of digital forensics is network forensics that is concerned with data in transit. Recently, mobile forensics also became popular. You all know that mobile devices are basically small computers, but they're specific, so we have to use some specific methods and tools that are going to explain later on. There's also multimedia forensics, so we can investigate images, audio, and video. And apart from investigated metadata, we also have to investigate the content, which means that we have to use image, audio, and video processing methods and tools. And also there are some exotic things such as IoT, embedded systems, etc. So there are some commercial tools available. Most well-known commercial tools used for computer forensics are EnCase by OpenText and Forensic Toolkit by Data Access. There are a lot of tools which can be used for mobile forensics. I'm going to mention just a few. It can be MSAB Field, Oxygen Forensic Detective, or Celebrite UFED. There are also some open source tools available. The most widely used tool used for disk forensics is Autopsy plus that is, let's say, a front end to the Sleuth Kit, which is a collection of forensic tools. The tool that can be used to investigate volatile memory is Volatility, and network can be used with Wireshark or any other network sniffer. What is interesting to notice is that you can boot Kali Linux, widely used penetration testing tool in forensic mode, and most of those, actually all of those tools and many other forensic tools will be available to you. So now we are coming to computer forensics. I already explained that computer forensics, or traditional digital forensics, is an area of forensics concerned with evidence stored on traditional computers. And by traditional computers, I think of laptops, desktop computers, servers, or etc. So basically, every device that has hard disk drive or solid state drive that we can take out, or any device then we can take a memory dump using specialized tools on thumb drives. This is the oldest area of digital forensics, and that means that there are many tools available. So we're now coming to another example, and this is really computing 101. We have to remind ourselves how hard disks work. Every hard disk has one or more platters which are covered with magnetic material that stores data, and they also have a head on an actuator that can move laterally. So each side of the flatter has a track, and we can switch tracks by moving the head, and one part of the track is called sector. Sectors are usually half of kilobyte large, and because of some performance optimizations, usually data is not stored on a single sector, which is physically the smallest addressable unit, but on something that is called block that can take more than one sector. And if we also remind ourselves how file systems work, we can see that each file is described in directory entry that contains file metadata and a pointer to the first block that contains data itself. Of course, each file can contain more than one block, and first block contains pointer to the next block, etc., at least in the case of fat file system. So what happens when we delete file? What would Windows do in this case? Well, basically it is going to delete only directory entry, which means that the data itself is still on hard disk drive, and it becomes so-called empty space. Also, what is important to notice is that file sizes are usually not products of block size, which means that that last block stays unused. A part of it stays unused, and that is called slack space. And we are going to come to that later on. So, for example, if you want to search for some data on computer, we acquired data using forensically sound methods, and we have to use some tool to find, for example, some piece of text. If the file is not deleted, that is a simple thing to do. We can use some, for example, I don't know, find Linux command or whatever to find the data. What happens if the file is deleted? Can you find the data? Well, we can. There are some specialized tools, and I already mentioned some of them. We can either use, for example, NCase or Autopsy to find that data. So I'm coming to some specific forensic tools. This device is calling forensic imager. It is basically a small computer that copies data from one hard disk drive or solid state drive to another. It is specific because it has support for different hardware interfaces, and interfaces on one side are write blocked, which means that this device cannot alter data on the source drives in any way. It can either copy drive block by block, it can make ASO images and calculate some hash values that are used to verify the integrity of the data. Usually the data is copied on two disks at the same time, because one disk is used for investigation and the other disk can be used as a source disk if something goes wrong with the first one. This is a little bit simpler device. It is called write blocker. That is a device that you can put on your desktop PC, and as you can see different hardware interfaces which are very similar to usual IID, USB, etc. interfaces, but they also they disable writing on the device. So if you're using that kind of device, then you're sure you're not going to alter the original evidence. There are also simpler write blockers which are used for particular hardware interface, but this one is, as you can see, cover more than one interface. we already said that we can use either commercial or open source to conduct investigation, for example, to find some piece of information on the drive. So now we are jumping to network forensics. As I've said, network forensics is an area of digital forensics that is concerned with evidence transmitted through a computer network. That could be, I don't know, Wi-Fi, Ethernet, or some wide area network. And we also have to remember some, let's say, networking 101. This is an Ethernet frame. What we want to notice is that after some synchronization data, we can find destination MAC address and source MAC address, and somewhere along the way, we'll find data itself. What is usually the content of this field here? Yeah. Okay, but usually it is usually IP protocol. So usually we are going to find IP packet there. And also I won't come into details, but what is important to notice that we can also find some source and destination IP address. Now in information part, it is here. We are going to find some higher level protocol. For example, it can be HTTP. And what can we do to investigate this data? We can use a network sniffer that can be a regular laptop computer, or we can use some external Wi-Fi cards with high gain antennas, and we can use any software that can display network packages to find specific part of data in that traffic. Of course, if data is not encrypted, but we're going to come to that later on. And as far as mobile forensics is concerned, we said that mobile phones are special kinds of computers, but they're specific. In the past, mobile phones were characterized by a large number of device types, a large number of hardware architectures, operating systems, and apps, and it was difficult to conduct forensic investigation because a single person could not know everything there is to know about that. But recently, there are like 90 or something % of the people are using either Android or iOS phones, and even hardware architectures are, let's say, coming close together. What is also characteristic with mobile devices that it is not as easy to come to the data as it is easy to come to the data stored on classical computers. If you have a screwdriver, you can take a SSD chip from the laptop, but internal storage on mobile phones is usually soldered. So we have a problem with that. And also modern mobile operating system and platforms use full disk encryption by default. So if someone has protected his phone with a passphrase and data on the phone is encrypted, we have a problem. It is difficult to get to the data. And however, on the other side, people use mobile phones more often and more intimately than their laptop or desktop computers. So in principle, they're more interesting in forensic investigations. What is also specific to mobile phones, especially the older types of mobile phones, is that each mobile phone uses a SIM card. And SIM card also stores data. It can store some data that can be of interest in forensic investigations, the identifier of the card or subscriber, but also it can store phone book, SMSs, call records, etc. Mobile phones are mobile, so they usually offer location-based services to their users, and that is the information that can be used in forensic investigation. I'm not sure that all of you are aware, but if you make a photo or video using your mobile phone, it can store the exact location where that photo was taken, if you didn't turn off that option in settings. Also, some applications that are using location-based services, for example, Google Maps, can cache that information, and you can get to the information during the investigation. That information is usually provided by on-device providers, either GPS or mobile or Wi-Fi networks, but also if we have connections with mobile operators or via the police, we can get mobile operator logs and extract location operation information from there. So each mobile operator keeps call-related data of each subscriber. So that data is kept for various period of time, depending on the country. But here in Serbia, each operator has to keep that data for at least 1 year. And the data kept is data such as time of the call, duration, source telephone number, destination telephone number, so we can see who called whom. But there's also some technical data which can be used to get device location. So even if your telephone is not using location-based services, it is enough that your telephone is turned on and you're going to leave a location trace to your provider. And this is something that we can use in the investigation. So this is one example of mobile forensic system. This is MSAB field, and it is basically a laptop computer with software, but it also has some set of cables so we can access all different types of mobile phones. It has SIM card readers and, for example, Faraday bags, which can be important because if we are investigating some phone that is turned on, we want to stop it to connect to the mobile or Wi-Fi network. I've previously mentioned that it is not as easy to come to the data stored on the internal storage. However, there are some techniques which can be used to extract data from internal memory. Most widely used techniques are JTAG, ISP, and chip-off. JTAG, or Joint Test Action Group, is an industry standard for testing hardware. And we can use this protocol to instruct processor to get data from flash chips. What is important to know is that this process is not destructive to the phone. Of course, we can always fry the phone if we do something wrong, but in principle, the phone won't be destroyed. If the motherboard doesn't support this protocol, and this is an example of a JTAG station which can be bought for under 100 euros. If the motherboard does not support this protocol, we can try to use ISP, or in-system programming, to directly image internal memory chips, such as flash chips. However, we usually have to fry several identical phones before getting the things right. And if this technique doesn't work, we can use the chip-off technique, which means that we are basically heating a phone to remove the chip from the board and then insert the chip in the memory reader, but in that case we are destroying the phone if we cannot use it anymore. So those are some techniques which are not as easy to use, but also there are some commercial service provider which can do it for you. Now I'm coming to digital anti-forensics, and in the same sense that digital forensics is specialization of forensics, digital anti-forensics is specialization of anti-forensics. There are different methods you can use to stop forensic investigation, but we are going to focus on technical attempts only. I mean, you can stop investigation by killing the examiner or by penetrating the forensic department, but that is out of the scope of this talk. I won't be specific about digital anti-forensic tools, but when I cover most widely used methods you'll be able to see which tools can be used. So I'm not sure that you can read this image. Just tell me if I'm correct. So that is why I also prepared several slides that show the same information as in the image. This is one classification of digital anti-forensic methods that were published in one research paper. So digital anti-forensics can be divided into data hiding, artifact wiping, trail obfuscation, attacks on forensic methods and tools, and indications of digital anti-forensics. Do you have any idea what could be data hiding? Steganography can be data hiding. Of course, what is steganography?
Encoding your information into an image so that to the plain eye it looks like an object.
Well, that's right, but we don't have necessarily to hide information in the image. We can also hide information in any other kind of data, for example, text, audio, or video. Or we can also use encryption. That is one method of information hiding. Of course, the adversary is going to know that there is some data, but he won't be able to read the data. And when I say encryption, I mean like encrypting the static data, files, partitions, whole disks, or encrypting data in transit at different OSI levels, for example, Ethernet, IP, HTTP, etc. We said that we can use steganography. We can use in something called data contraception. What could that mean? Any idea? Well, don't produce any data in the first place. Don't keep log files, .cache files, use private browsing mode in browsers, etc. We can manipulate file system or hard disk. I already explained several techniques. What we can also do, I mentioned that there is always, most of the time, some empty space on hard disk, and also there is a slack space at the end of some blocks. We can use that space to store some data that won't be visible to the operating system. We can also, for example, use some hidden partitions. They can be easily recovered using forensic tools, but if you try to boot your operating system, they won't be visible. We can hide data in volatile memory, and we can also hide data somewhere on the network. The second group of anti-forensic techniques is called artifact wiping. So we are basically erasing the data. How can we erase the data? So probably the most safe thing to do would be to physically destroy the disk. But we can also use special tools that wipe your data. So if you remember that picture I saw previously, when we want to erase some file, we won't just erase the directory entry, we are going to rewrite all the blocks, probably several times using zeros, ones, randomly generated bits, etc. So I don't have much time, so I'm going to skip something. Of course, we can wipe files, partitions, disks, or metadata, and we can also use trail obfuscation, which is usually used to dwarf network forensics. For example, we can spoof MAC address. We might be able to spoof IP address, but that is not as easily done because most ISPs won't allow that. We can use some proxy servers, Tor network, or some other methods. And what is also useful to know is that we can attack the forensic methods themselves. So we can use software that is going to detect forensic tools run on the device, or we can also try to attack the integrity of the evidence. I previously mentioned that we image some data on the hard disk. We always make a checksum to be sure that evidence is integral. If we get to the evidence, we can just switch few bytes and it won't be valid anymore. So I'm going to skip that and come to another example. I want to try to discuss one fictional forensic investigation and to try to identify some forensic and anti-forensic methods that could be used. So, for example, we could have some case of child pornography. Someone detected that child pornography is being shared on a peer-to-peer network, and police successfully identified the IP address. With the help of internet service provider, we were able to get information about the subscriber and the device, and it turns out that device in question is a Wi-Fi router, and that on the suspect's address there is a five-member family living there. So police goes there, they sniff open Wi-Fi traffic, and later on they enter the premises and find several devices such as laptops, smartphones, and different kind of memory. So when we come to network forensics, which method can we do to do network forensics? I already mentioned something. What information can we get? Okay, we can sniff the traffic if it is open. We can find discriminated data in the traffic, and we can find what?
First, to find how many devices are actually using it.
That is very important. And we can find MAC address of the specific device that is sharing the discriminating files, for example. And that is something we can do. As for computer, how can we fight against those techniques?
Well, don't use your Wi-Fi. Use the ones in your neighbor's house.
That's correct. Even better if neighbor has encrypted Wi-Fi and we know the passcode. Are there any advanced methods? We can spoof MAC address, we can use VPN, we can use proxy servers, we can use Tor network, whatever. When it comes to computer forensics, so what can investigators do? For example, if all the computers were turned off, there isn't any data in volatile memory. We can make images of HDDs and SSDs and try to find compromising data. And if you want to fight that, how can we stop it? We can encrypt data, we can safely erase data, we can hide it using steganography, but that is not real because you usually cannot hide a lot of data using steganography, etc. I mentioned that someone found out that files are shared using peer-to-peer network, so we can try to find some artifacts such as log files and cache files of the peer-to-peer app, and we can use that to prove that they were shared from specific device. When it comes to mobile forensics, we can also use the techniques previously mentioned to acquire data from mobile phones, and we can also use mobile operators to get some additional information. To fight that kind of investigations, what can we do? Well, if you're using some new Android devices or iOS devices, it turns out you don't have to do basically nothing. You just have to set a strong passcode on your device, because it already encrypts all the data, and if investigators cannot enter the phone or if it is turned off, it is very hard to get that data. So to conclude, anti-forensic methods and tools are becoming a formidable obstacle to the digital forensic community, especially when it comes to mobile forensics. There is a cat and mouse game between digital forensic methods and tools and digital anti-forensics methods and tools. In the same way, there is a cat and mouse game between attackers and defenders in information security. Both digital forensics and anti-forensics are interesting research areas. Digital forensics is becoming a sought-after profession with the proliferation of digital devices, and digital anti-forensics can be used to protect privacy, but it can be also used or misused for some criminal purposes. I suppose that the organizers are going to share those slides with the audience, so I just left some references, some books you can read as introductory material into digital forensics, some certificates and courses that you can take if you want to start practicing this profession, and also there are links to some organizations. You can visit their websites and find a lot of interesting information. And at the end, I want to use this last slide as a commercial. I said that I come from Faculty of Technical Sciences in Novi Sad. Next year, we are starting a master's program in information security. So if there are some four-year students here, they're welcome to check the sites and apply. This program is going to cover courses from cryptography through computer security, network security, secure software development, critical infrastructure security to digital forensics. And more information will be available in roughly half year at those addresses. So thank you very much on your attention.